Welcome viewers to Bodhi Unified Flow. Here we simplify complexity and amplify performance. Today, we're diving straight into a real game changer for finding inefficiencies in project life cycles. We're mastering step 2 of value stream mapping, the current state map. More specifically, we're going to look at exactly how you document the as-is process, right where the action actually happens, out on the shop floor or the construction job site. So if you've ever felt like your project is just bleeding time or resources, but you can't quite put your finger on where the leak is, well, this explainer is designed exactly for you. All right, here's a quick look at our agenda for today. After our welcome, we'll dive right into the principle of Gemba. Then we'll cover tracking material and information, unpack the VSM icon toolkit, explore how to identify wastes and gaps, and finally, wrap things up with a summary and our references. Let's get right to it. By the end of this session, you're going to walk away with some serious, actionable skills. You'll fundamentally understand the Gemba observation philosophy. You'll be able to clearly distinguish between the flow of information and the physical flow of materials. We're also going to make sure you can utilize the specific predefined VSM toolkit icons to visualize your data. And, most importantly, you'll gain a really clear methodology to identify that as-is current state gap directly at the actual place of work. Now take a look at this 6-stage VSM methodology. Notice how stage 2, mapping the current state activities, is the absolute linchpin of the whole shebang. You literally cannot identify problem areas in stage 3 or design a fancy future state in stage 4 without a ruthlessly objective map of what is happening right now. Trying to optimize a process without a meticulously grounded understanding of its current reality, it's kind of like trying to navigate a brand new city using a map from 100 years ago. It is a guaranteed recipe for getting lost. Okay, let's kick things off with section 2, the principle of Gemba, or moving from the office to the action. To build a truly accurate current state map, we have to embrace this principle of Gemba. It's a Japanese term that basically translates to the real place. For us, it means getting up, leaving our comfortable office desks, and going out to the actual place of work to observe processes in real time. We literally have to abandon idealized standard times, historical records, and managerial assumptions. We're out there to collect objective, first-hand empirical data. You want to observe the work exactly as it happens, with all its beautiful complexities and frustrating delays. We're talking about documenting how a sudden weather change forces a shift in activities, how misaligned deliveries leave crews just standing idle, or how workers spontaneously solve unexpected clashes on the fly. Those are the vital factors that standard operational times literally never, ever account for. And if you need a solid reason to actually go out to the Gemba, just consider this staggering statistic. On average, only 54% of planned tasks are actually completed on time. Yeah, 54%. That means traditional schedules are wildly overestimating reliability. Nearly half of what gets meticulously planned in the office simply doesn't happen as intended on the ground. So think about it. If you build your baseline map based on what the schedule dictates should be happening, rather than what is actually happening in the mud and dust of the job site, well, your entire value stream map is just going to be a work of fiction. Reality is messy, and we've got to capture that mess. Which brings us right to section 3, tracking material and information, and how we document those flow paths. When you're out there observing, it's totally crucial to contrast these two different flows. First, you've got information flow. This is the administrative nervous system of your project. How are orders placed? How are schedules communicated upstream to suppliers and downstream to the crews? We map this to find communication bottlenecks. Then, we have material flow. This is the gritty physical movement of your actual resources. Where do materials enter the site? Where are they stored? How do they get pushed to the next process? Documenting both of these parallel streams is an absolute must. Imagine a scenario on a site where a skilled mason is standing right next to a massive, perfectly stacked pile of bricks. The material flow is completely flawless, but he can't lay a single brick. Why? Because the site foreman hasn't received the digital sign-off from the structural engineer. So the material is ready, but the information bottleneck has completely stalled production. Mapping those flows is the only way to reveal those hidden disconnects. Now, there is a bit of a unique challenge here, especially for those of us involved in complex, large-scale projects like construction. Unlike a highly controlled indoor manufacturing assembly line, construction production time is way higher and incredibly susceptible to external variables. Because of this high variability, it's practically impossible to get reliable data for your current state map in just a single afternoon. So we have to track the whole process of the activity repeatedly. We observe the exact same sequence multiple times across different days or different shifts to calculate a reliable global average. This kind of rigorous, repetitive observation is what ensures your map actually reflects the true baseline reality rather than being skewed by a uniquely fantastic or, let's be honest, an exceptionally terrible day on site. Let's move right along to Section 4, the VSM Icon Toolkit, and how we actually visualize the job site. All right, think of these predefined icons as a universal language that translates complex job site activities into simple, digestible visual data. First up, we've got the process box. This represents a distinct work step. Inside this box, we capture the hard metrics. For example, cycle time, which measures the exact amount of time it takes to complete one specific task from start to finish. We also document changeover time, which is the duration required to switch a machine or crew from producing one type of output to another. And we log equipment uptime. Next, we use the inventory triangle. You place this wherever materials or work in progress physically accumulate, and you actively note the quantity that's just sitting idle. Finally, we have the spiral. This is a supercritical icon representing where a planned or occurring delay is happening, maybe due to unavailable manpower or just waiting on preceding tasks to wrap up. Now, we also have to map how instructions and resources actually move between those process boxes. For manual data, like physically handing over a paper report, we use a straight line arrow. But for electronic data, like a signal from an ERP system or an email, we use a broken or zigzag arrow. To show physical goods moving, we use a specific push arrow. This indicates material is being forcefully pushed to the next downstream process, regardless of whether they're actually ready for it yet. And finally, my personal favorite, the Kaizen burst. This is a jagged, standout icon that we drop in to aggressively flag critical problem areas that demand immediate attention. The Kaizen burst is honestly a game changer because it stops your map from being just a passive historical document and instantly transforms it into an active, strategic tool for making immediate improvements. Which leads us perfectly into Section 5, identifying wastes and gaps. This is the real payoff of all your mapping efforts. Once your as-is map is all drawn up, it acts like a diagnostic X-ray for your project. It gives you a stark visual representation that instantly separates your value-adding activities from your non-value-adding activities, the wastes. It clearly identifies the actual sequence and continuity of your project from end to end. By tracing the flow, you'll immediately spot where those inventory triangles and delay spirals are chronically accumulating, highlighting massive productivity setbacks. It uncovers systematic, structural issues that are just hiding in plain sight within your current approaches. By making the invisible visible, this map hands you the exact data-backed targets you need to go out, eliminate bottlenecks, and aggressively maximize your project's performance. All right, let's bring it all together in Section 6, Summary and References, consolidating what we've learned today. Look at what we've covered in this session. We've successfully navigated the exact mechanics of creating a current state map. We established the foundational truth that you absolutely must physically go to the Gemba to capture empirical reality, completely ditching those comfortable office assumptions. We learned to map both the gritty physical material flow and the invisible information streams that govern it. We also explored how to translate messy field observations into structured visual data using the VST toolkit icons. So, with these highly specialized skills, you are now fully equipped to identify the as-is gap and perfectly positioned to start designing a highly optimized future state. I want to leave you with this one final, provocative thought. Take a look at your own projects. Are idealized assumptions hiding the inefficiencies on your job site? Because honestly, if you aren't documenting the real work directly at the Gemba, tracking the actual flows, and meticulously drawing out the map, what unseen wastes are currently sabotaging your project's performance right under your nose? For those of you who really want to geek out and deepen your practitioner's playbook, here are the foundational research references cited in today's explainer. We've got everything from Rother and Shook's seminal Learning to See to Howell and Ballard's vital insights on project-level performance. Thank you so much for joining us at Bodhi Unified Flow, where we continuously strive to simplify complexity and amplify performance. Until our next session, keep mapping, keep improving, and get out to the Gemba.